How are you? My name is Anton. I'm the English manager at ManyChat. I'm working here about 6 years already. So today I will tell you a little story about current bottlenecks in PHP projects. And this presentation mainly about principles, not about examples. And I will talk about this a little bit later. But before, a couple of words about ManyChat. As I already say, this is a marketing automation platform. And we're working with the different channels of communications in the world. And mainly, this is a specific tool, specific instrument, professional instrument for the visual development of communication between businesses and customers. When I'm talking about visual development and visual tools to develop something, I mean that our users, our customers, could use just visual tools to define and design a flow of communication with automations, with different ways of automations. You can check and then test it in our site. This is free, but this is a little bit important to give you a context about our platform before this presentation. Because in numbers, it looks like this, more than 1 million active businesses. And when we're talking about active businesses, this is real businesses connected to ManyChat worldwide in more than 170 countries in the world. Mainly it's US, Latin America, and Europe, of course. But we are worldwide, and when we have a big conversations with our customers, we can make conferences for people who are going to us from, I don't know, Australia, New Zealand, Asia, entire Europe, Canada, US, and Latin America, of course, with Brazil, with Argentina, and this is our main focuses right now. So, more than 1 billion messages per month we are sending, users sending through our system. More than 1 billion events every day, and more than 1 million webhooks every minute in our system. So we know something about performance in PHP, because we are still not so big team. It's about 40, 45 persons in development, and we are collecting real nice developers from the world to make our projects really stable in a, I don't know, not so big headcount. And what I will talk about is today. It's about development, usually without considering about topological and pathological complexity of applications and how it works related to servers, related to meshes, and how it works with the different approaches in different systems. But mainly it's about a little known but very well, I don't know, common and spread design pattern we're calling a header. Do you know what is this? Nice. Yeah, we had a question before about this, because mainly this presentation was inside the company, and everybody know what is this, and it was interesting about a new experience. So heater, this is much spread pattern, because everybody knows that data centers, it's a very cold places for servers. Just making this, it's a big fight between developers and system administrators. For the temperature in data centers. All of system administrators trying to make it cold, and all developers trying to make it hot by a ton of useless and redundant operations in processors and in memories, and this fight like with a, I don't know, way and line of the history of development. I will show you a couple of, I don't know, principles mainly, how to think in development with your application, basically as a development for a computer, not for a human. So, our plan for tonight. I will tell you why it works like it works right now, and why we have this experience right now, why we see something we see right now. When we're talking about research baseline, what we are looking for when we are developing an application and when we are writing a code, and how we think about this. And a couple of examples, like to work with exceptions, with file systems, with, I don't know, human readable protocols like Json, maybe a couple of words about regular expressions and work with database. That's not about rocket science. That's about absolutely common questions, but I will show how it works in real life. So, why it works like it works right now? Maybe someone of you already know about Moore's law. This is dependency between time and transistors count replaced and represented in processors right now. And it increased twice each 18 months or 1/2 1.5 years. And usually it's represented in a David House interpretation, like in last 20 years. We already have about x 290 times of count of transistors represented in our processors. Now, it's a worldwide things, and this is just industry standards. But below, you can see another one number. It's 500,000, 500,000 times. Does someone know what it means? No, okay. And this is about algorithms power increases this time. So we have about 290 increase times in processors, transistors count, and thinking that usually this is the main reason of our powerful computers right now. But mainly we have this impact and this powerful of our systems because we changed algorithms. I mean, not we, ManyChat, we industry. A ton of mathematics, a ton of people who works with algorithms, works in processors, made more impactful things about this speed and this performance right now. And that's the reason why I'm talking about a performance in this presentation based on algorithms, not based on a powerful of machines. Because when we just get in a simple, I don't know, very simple project, like here, you can see that this is absolutely common things with scanning users, connecting to database, writing logs, maybe some actions with Json, maybe some actions with, I don't know, regular expressions. Nothing special, absolutely. Usually for these presentations, people using a complicated system who is connected to, I don't know, different database like a Postgres, SQL, MySQL, MariaDB, Redis additionally, Golang, Node.js, and then they try to orchestrate all of this and explain how to make it more performable, a more performable system. But my target here is to show how to change your own system without any conditions how it looks right now, because you can see all of these lines in your project every day, and I guess everybody of you have the same things here. So nothing special really, no ORMs, no frameworks, I don't know, some example from Stack Overflow, and that's really easy to read and understand. And our very motivated developer goes to run this project just to scan users and go into drink a coffee, speak with colleagues, look at YouTube, read Medium, and a couple of hours later, they are back and look at this. It's like a 786 users per second scanning speed. This is just a metamorphical metrics, just to understand and getting some baseline of this. And how we will look and how we will understand is everything okay with our system or not. We will look at Pinba. Pinba is a tool to profile PHP processes in runtime. This is really old, but this is really effective because this is like a first tool in the world was released to profile PHP in runtime using UDP protocol without any impact to a system and writing it directly in a MySQL temporary tables. That's a little bit context. That's not so popular right now, only on very high loaded, because right now we have a PHP Spy, for example, any Xdebug tools, but all of these tools have an impact to processes, and you can't use it in runtime every day. Pinba is a representation of a parameters we are recounting, and we need to understand only three of this. It's like a row utime, row s-time, and memory footprint. It's memory footprint, it's a self-obvious thing, because we are talking about how much memory our application using in the moment. But row utime and row s-time, it's a really interesting and important thing. And to explain why it's so important, I will show you this a little bit complicated schema, but actually it's simple, because I found a most simple thing of a POSIX and an operation system core interactions. Because every time when you are running a code in your own application, usually it works with a user calls, like a code executed in your own engine, PHP engine, for example, Node.js engine, Golang engine, doesn't matter. But each time when you are going outside your application, you are going to not directly to another one resource. Like, for example, if you are going to a database, You are not going to a database. You are going to operation system core and ask to get an access to a database. Ask to get access to file system, reading files, writing to files, some additional actions, I don't know, saying something using network, and each time it using specific system calls, syscalls. Now, why it's happening like this? Because the POSIX have two targets. First, work with the concurrency, of course, because a lot of applications could have an access to files, for example, in one moment. That's the most common thing to realize, that we have to organize some queue in operation system to get an access to this allowed resources. And another one, to protect an applications, because an application is really restricted to have an impact to another applications, because it's a protection way. In a most simple things, this is like a, I don't know, firewall for other applications to work with another one application. We are sending requests using operation system core. We know about some workarounds, but usually it's going like this. So, time calls, it's operation run in the user mode, in the user code, in the PHP engine right now. Syscalls, it's each time when you're going outside PHP engine, like a reading file, database requests, any external request to another system, and something more. And memory footprint, it's the most easiest thing, but I guess a lot of you know about a specific of how PHP allocate a memory from operation system. It's always using the buckets with two linked lists and getting memory it needs and a little bit more just in case. Like, for example, if you need 8 megabytes of memory to execute your application, PHP will get 8. But if you need 9, it will get 16. And then, if you need, I don't know, 20, you will allocate about 32 megabytes of this. And going next, twice. Using a quad logic, you can go to a way when you asking about 2,100 megabytes of memory, and PHP allocate 4,096, but with like quad logic. This is a little bit important for this presentation, but mainly we are not have cases when we work with so big and huge memory footprints. But anyway, in one moment you will see about this. So, the first steps of this. Exceptions. A lot of people like it, me too. Not so all, not always, in different cases of course, but mainly it works like this. When you are using an exceptions in your code, usually you work with a specific isolated code area. Operation system and PHP engine should process additionally, like it's a covering space. And for this covering space, the system using additional resources to allocate it, to use it, to protect it, and each time when you are throwing an exception by different cases, it should collect a stack trace, parameters of different classes, of, I don't know, calling stack, of collected as build it to one report and put it to some backtracking system. You can see like rollbar or sentry, for example. You see this all lines of execution with all parameters, and all of this data PHP must collect, transport to a human readable state and send it somewhere. And in this moment, you can lose about 7% of your application performance just to using and try and catch, and without anything. And when you are throwing an exception, it could decrease performance of your application up to 4 times, just because it's break everything. It stop an application, collect this report, collect this stack trace, parameters, transport it, translate it, and then it going application next to some endpoint, for example. Just 7% when you're just using truncation. It's not an, I don't know, exceptional situation when you don't get something from database. This is absolutely expected because this is a real life, and we don't, I don't know, keep a 100% consistency of data. We can just return a state like null now here. Nothing changed really. It's really comfortable. I can accept it because throwing exception in one place and catching in another one without control all of this way, this is really comfortable for developers. But that's not so comfortable for computers. And when we are writing a code, we are writing it for computers, not for people. Mainly two people will edit it, read it, but that's not so big difference. That's could, I don't know, it's an economy about a couple of seconds of writing code, maybe a couple of days when you are collecting a big system, but in real life, when you're running it to a high-loaded system, it could break all of your production in a couple of ways. Just imagine how many try catches you have in your projects, in a big project. About, I don't know, 50,000 lines of code with a team about 100 people. There's a difference between, I don't know, buying servers, building balancers, and thinking about routing, and or find a specific way to avoid this practice. So, in real numbers, we don't have any economy of user calls because it's a system control, actually, because this is nuclear and core actions. But about 5% is syscalls, less to 5% in calls to operation system, and half of memory footprint. This is just in case when we really lost half of memory allocated before, just because we don't need, I don't know, another 1 byte here, because try catch making another memory footprint, of course. So work with file system, most cheapest case about file put contents. I guess everybody knows this syntax sugar to write something to a file, but a lot of people using it like, I don't know, way to work with that every day. It's different operations, but very simple. File pull contents, something to file and add something with a file up and k, nothing special. But then when we're just moving it to work with a file descriptor, we change everything because we are getting a specific access in using this descriptor in loop to handle this writing way by way, and how it works and why this principle still works. Because file put contents is just f open, f write, and f close in one function without additional actions. This is syntax sugar, and when you're using it in loop thousands of times, it's each time getting a file descriptor from operation system using POSIX. It's a request and access to a file, standing in a queue, get this request, get this access, and getting this file descriptor, and then write, then close. It's like a free, this resource. And then in next iteration, it's again f open with a waiting of this access and going next. And it's not so interesting by development, but interesting by metrics, because we can see that we get about 11% in user calls, because we're not doing these operations each time. We're getting this descriptor only one time. And about, I don't know, 26% in syscalls we're not. We made just one system call to operation system to get this descriptor and not repeat it each time. I guess it's not so hard to understand, but it was like this. A little bit change from one line to a couple of lines, and you can get about 26% of performance when you are writing logs. JSON is a representation of all human readable approaches, because JSON, everybody likes JSON. It's an old human readable protocol and all human readable format, and we work with that every day. But in a databases case, for example, it looks like you getting user, creating a specific entity, specific table, user ID, username, password, email, maybe timestamp of created, maybe, I don't know, phone, and additional data. And then in a lot of our tables, we can see a specific column with name data. And data we are filling out and filling up with absolutely unpredictable structure cases. We can use, I don't know, for just in case, for example, it's a little bit lazy to add a column each time when we can predict an architecture in future. That's absolutely normal. But it works like this. We can get a little impact if we are not using JSON decode. In some cases, this is a little bit economy, but imagine when you have, I don't know, 1,000 of these lines of JSON decode in your own project, and it could be really a lot, because JSON decode still works from extension. That's not a native function. That's a lot of mathematics for processor. And this is still human readable protocol, and it means if it's really comfortable for people, it's really uncomfortable for computer. Why? Because in main case, it could be fast when we work with the, I don't know, English alphabet, with the UTF-8 system, but with ASCII tables. And we are now getting from 0 to 9, and we are getting from A to Z, everything K. That's easy that's absolutely light and absolutely not wet. But when you're going to, I don't know, some international things, and when you're working worldwide, it could be about 68 byte, 64 byte to one symbol in your writing, just one. And it could be very wide. And each time when you try to decode, I don't know, some parameter like is private bool, you are decoding all of this line, and you are decoding all of these symbols in a different UTF-8 protocols and different UTF-8 schemas for different languages each time. It could decrease a performance of your project. Like here, it's just UTF-8 and with the English alphabet. Like we're in an ASCII table. And this is a small impact about just decoding it. But if you are going to a next step and working worldwide, it could decrease your performance twice. Another one thing, regular expressions. This is like a, I don't know, specific way of developers. Nobody knows how it works at start of career. But each time when a new developer getting a new knowledge about how is regular expression works, it could be represented in your project everywhere, just with a new chance to replace. It's like a testing of new technologies in your own project, in the project of your company, just because you know it well. It's you found these cases on code, for example, and after a couple of weeks, your junior developer coming with you and getting and putting a lot of regular expressions in your code. But usually, I found about, I don't know, 1,000 things in one project with using regular expressions with cases like this. It was one company before, but it was a base of this presentation mode, because the developers just using regular expressions to find a couple of symbols in the line of string without, I don't know, for example, embedded replace line. And it could be, looks like some cheapest way, but in real life, regular expressions is a very powerful native language tool, and this is not so powerful without resources, because we can get just changing in one line. It's about 5% in user calls and about 4% in system calls, because regular expression still works using system calls. This is an extension still too, and that's not in core. Nothing changed in memory footprint. I understand when we're looking on this slide, it's like, I don't know, a cheapest change just to change, but in metrics, it's a 4.6 and 4.1. And where we're comparing it with the different things in project, in big projects, in high loaded, with which works with, I don't know, for example, we have about 40,000 requests per second into our servers. And it's 40,000 times to get an economy of 4% of performance using a different way. It works like this. So, and it means here, like in array, not so big, impact, but could improve it, because when we're using just a linear array and try to search it with in array with a specific parameter true, that we try to find it an exact position, we're always going to linear search from symbol to symbol, from first one to next one we are founding. Like if you are try to search a status 9, like here, you will go into all symbols of this each time when you're trying, and this is like a predefined. But when you're going to just a map, this is a simple case to getting from ON, please, to O1. This is from a linear to constant thing. And you can see the results. With a constant, with a so small array, you can get about 6.5% just in user calls and about 4.5% in sys calls. I know that in code it looks like, I don't know, changed for beautiful, but in metrics it is always interesting. So, prepared statements. Maybe someone of you already know about prepared statements. Okay, a little bit disclaimer and a little bit spoiler, it not works everywhere. But before first, PHP really realized they can't do something with prepared statements, because PHP think about emulated prepared statements first. One of databases already had this function, and if I'm right, it was Oracle maybe, or not. Anyway, One of databases engines already have a prepared statement thing in their engines, and they are supported. And when PHP realized this, they just give additional support of these things and this function, given a specific tool. But because all of engines in databases not supported, they built a specific mode of this, the emulated preparations. And emulated preparations worked in the PHP a ton of years. And when I started to work with PHP, it was about 5.2, I guess, maybe somewhere. It was true by default. And then next version false by default, next version true by default, and then switching, and this was absolutely unpredictable way to work with databases if you are not using your own hard configuration of this. Anyway, up to 7.2, I guess it was mainly true by default, and then we are going to some performance way. So this is a start point, 1,700 users per second. We are scanning to with PDO, preparing this request and binding values without any specific cases. But when we are going to preparing statements, we can receive this increase of our performance. And this increases works like this, because that's still nothing special. We just prepared this statement and using it to connect to our database and work with that, I don't know, with a specific way. You can see that's not so big difference because we're just preparing statements, and but in database state it works like this. Usually we send in a request to database with values, with I don't know, query, and getting a result, fetching it and reading it and everything key. But when we are using, I don't know, loop request for a different list of users, for example, or for different records in our operations or events, and we are requesting same request each time with same time, each I don't know, each operation, we sending a request and forcing database to analyze it. Because database have a lexical analyze, morphological analyze, preparing this request, making a plan of execution of this request. It's just to let you know, it's 97% of executing database request is the preparations. It's exactly executing way. It's just a 3% of this. It's reading data and return this data, nothing more. 97% to check that everything okay. And when we are preparing statements, when we are saying to the database just to prepare this statement and this query, we just sending this query and saying, give me a statement about this. Database will analyze all this, will make all preparations, getting your state, and then you are just binding values. Binding values, getting result. Binding values, getting result. This for all these requests, the database will use just this one prepared statement and nothing more. It's just sending values and getting results. But it not works because first time I prepared this metrics and a matter of different project, it was a COVID time. And yeah, I started from 7.1 PHP, and that was one result. 7.2 give me another one, and it really became slower with these principles. And 7.3 giving me a faster result, and 7.4 giving slowly again. So check it in your own project, please, and don't use it with the spreaded servers like PostgreSQL, balanced multi-database ways. But in a single ways, it's still really a nice way to give us some chance to make your application more performable. So 7.4 was the last one, and then I tested it in 8.2, I guess. And without prepared statement, you can see, and with prepared statement, we really get about 15% in user calls and about 3% in syscalls. Not so special, but we, I don't know, got about increase 100% in memory footprint. That not means that we make less operations. We just move this responsibility to database. Because now it's database preparing requests, not PHP. And so, but anyway, to be crystal clear, the database always faster just because it's binary. And it's the easiest way to find the performance. Think about this twice. So, in conclusion of this, I can say that we made just 5 elementary actions, changed and exceptions to state, I don't know, reused handle instead of output contents, any useless operation, and additional lies and checks. I don't know, no rocket science, as I already said before, but actually we just removed absolutely useless operation for our memory, for our processor, for our disk, and for our network. That's about, I don't know, in total you can see that we save about 46% in user calls, 32 in system calls. Memory footprint was same, and 280% in the speed of processing these user calls. You saw these really simple actions. That's not something difficult to understand, and you can find this in your own projects and find how to make your own applications more performable. And I still think that best of the best practices is a meaningful development when you are thinking about machines like machines, nothing more. That's all from my side. I'm ready to